Okay, this device is Atwood's machine, and what this device does is, so obviously this is heavier than that. Um, this mass will accelerate downwards and this will accelerate upwards. If these two masses are equal, the acceleration will be 0. If this mass is 0, this acceleration will be g. So here's a device that can give you an acceleration for this guy anywhere from 0 to g. Actually, okay. So that's what this is. Okay, it can give you minus g if this is 0 and this is massive, so it can give you minus g. Okay, so anyway, so this is an invention of Mr. Atwood, and that's why it's called an Atwood's machine. Assume that the masses of the string and the frictionless pulley are negligible. So what we're going to do is we're going to analyze this device assuming the pulley is frictionless and massless. And what that tells us is, if that is true, then the tension in the string on either side of the pulley is the same. Okay. Find the equation for the acceleration of the two blocks. Okay, so let's do that. So we'll say the tension in this is, okay, we'll assume M2 is greater than M1. Okay, so the tension on this object is, so gravity on this object is acting that way, and M1 will accelerate upwards. Okay, M1g. Okay. So for M2, we'll assume downward direction as positive. Okay, it doesn't matter what you do, but you will assume downward direction as positive. For this guy, for M1, for a different object, you can assume a different axis, and we'll assume upward direction to be positive. Okay. So for the equation for M2 is M2G minus T is equal to M2A. And for M1, it's T minus M1G equal to M1A. Okay. And what is it that they're asking us? Find the equation for acceleration of the two blocks. So there are the equations. Find an equation for the tension in the string. So the tension in the string is M2G minus A. And C, find both the tension and acceleration when the blocks have mass 2 kg and block 1 has mass 2 kg and block 2 has 4 kg. Okay. Now for part C, let me write down these equations again. M2G minus tension equal to M2A, T minus M1G equal to M1A. If you add the two equations, the tensions will cancel. M2 minus M1G equal to M1 plus M2A. Alright, so what we have is A is M2 minus M1G divided by M2 plus M1. Alright, so let's do the following. Let me actually fix this. Let's fix this in a second. Alright, so for M2 equal to M1, acceleration is 0. In the limit M1 going to 0, in the limit M1 going to, well, in the limit m1 going to 0, these terms will be 0. A will be m2 divided by m2 times g. Okay, so A will go to g. In the limit m1, m2 going to 0, m2 going to 0, it will be minus m1 divided by m1. A will be equal to minus g. Okay, so here is a device that can give you an acceleration of minus g to g. The minus sign just telling you that, what we have chosen is this direction to be positive. So the acceleration can be g in this, oops, what happened? Acceleration can be in g in this direction, or if the other mass, this mass is 0, okay, so what we are saying is if m1 is 0, a is g, and if m2 is 0, a is minus g, and this guy is going up. That's all. Okay. Alright, so there's the device. This is the expression we want, and we'll use this expression in lab. Okay, so we'll do this experiment. So the acceleration in terms of g is related, is given like that. Okay, and what is that we want? Find both the acceleration and tension when the block masses are given. Okay, so let's the acceleration is that, and you can use to calculate tension, you can use this equation, either one. So this equation tells you tension is m2g minus m2a. And tension works out to alright, so that's the tension. And I believe that finishes that problem.